Hello everyone, this is Amritpreet Singh,
Hello everyone, this is TIngxuan here.
and this is
Today we're going to present our machine learning final project, the dog breed classification using machine learning.
So this is the abstract. Dogs have many breeds, and it would be interesting if a machine could differentiate the breeds based on an image of dogs. So in this paper, we trained 5 machine learning models on a data set of 18180 is the training and 1200 is test images of dogs. And these models were able to classify images of dogs into 120 breeds. And data set was obtained from a Kaggle competition. And the 5 models that we constructed are CNN, logistic, decision tree, random forest, and KNN. The best accuracy we got was for testing 26.08, and the training was 60.47 for the CNN model. Yeah, and we used Google Colab. Yeah, and it took a very long time. If we had access to better resources, we would have been able to experiment more and potentially get a very better accuracy, but we were limited. That's why we have this accuracy. It sometimes took 2 hours to train one hyperparameter, like one model, and we had like so many different ones. Yeah.
Yeah, and this is the Kaggle competition we found in the in-class competition. We found the data set here, which is a dog breed classification competition. Yeah.
So the data set, as I said, these many images of dogs. Training set is this many, and test is 1,200, and there's 120 breeds or classes, and these are some of the images. This is the Chihuahua.
Yeah, and here are the 5 models we are using: CNN, logistic regression, decision tree, and random forest, and KNN.
So how did we acquire data? So we used this URL that the competition gave us. The competition was conducted by Purdue University, and they gave us an easy link which we could just use. So we just do this and then we unzip it.
Yeah, and this is how we extract the data. First, we read the directory and convert the image into the RGB. So, and then transform it into the numpy array, and then append this data to the X and Y. To the
So we do that for test the directory as well, and then for train it's train, and then we change them into NP arrays. Yeah.
So here, as you can see, we have 18,000 photos for the X train and 120 different classes for the Y.
So the other thing we did is we also made a flat one. So that this Y is not actually flat. This Y is a 2D array, but we made a 1D array Y. So we use dimension reduction here. We flattened Y test and Y train with Sarah algorithm. Very simple. So the flat shape is just 18,000 and then 120. So this will be used by other models other than the CNN. The CNN will use the non-flat one.
Yeah, and this is the image data generator we used from the Canvas API. And this is how we generate, this is how we do the data augmentation, how we augment the data with the Canvas API. And as you can see, we read the data from chain and validation to directory and split it into chain dataset and validation dataset. And each photo will be resized into 64 by 64, and the dashboard size will be 256, and we use the stars as the class mode here. So we can grab the Y, set the classes. So the Y would be a 1D array.
So this is the CNN model. So as you can see, we have 6 blocks first. So it's gone 2D layer. So these are the blocks, the sequential model. So you can see we're using ReLU, and we also use ELU. So we have 4 versions of this model. So we used this is where we used image data generator, and this is where we augmented the data ourselves. So there's 4 versions of this model, 4 scenarios with ELU and ReLU, and these are the test accuracies we achieved from each of them, and highest one was auto with ReLU.
Yeah, and here is the logistic regression model we are using.
Yeah.
And we do a dimension reduction here, and in this model, the mass iteration would be 10,000, and we reflect the data here and fit the model with the data. And as you can see, these are the alpha and beta results we have.
So this is the decision tree. So you can see we use criterion Gini and we use entropy, and we use different max depths. So this is the table that so with Gini we used 5 different max depths, and for entropy also 5 different ones. And for each one, this is the test accuracy that we achieved. Yeah, so the maximum is with entropy with max depth of 1.33%.
And this is the random forest model we are using. And we also use different criterion, Gini and entropy, and different estimator here. And as you can see, the highest accuracy we can have for the random forest model is using a Gini criterion and 250 estimators, which has 1.833 test accuracy.
So this is the KNN. So as you can see, NA versus 5 here, but we did a lot of tuning, and we ran it with multiple ones. So we ran it with 5, 10, 50, 100, 500. So these are the accuracies tests that we achieved. And yes, 1.08333 is the highest we achieved, which was with 500 N neighbors.
And as you can see, after we do the machine learning with these 5 models, and the highest one, that one with the highest accuracy is the CNN model, and it has around 26% accuracy, the highest one. And yeah, as you can see, the other one is the accuracy is around 1%.
Yeah. So I would like to say one thing. The reason we couldn't use it to 100% was because of hardware restrictions. Training each of these took almost 30 minutes, and training the decision trees took up to 40 minutes for each of these, and training CNN took like 2 hours for each. That's why we were restricted. If we had better hardware, we would have been able to get very much higher accuracies, and if we had better hardware, we would have been able to augment the data even more. But
Yeah.
unfortunately, we were restricted to Colab's hardware. So yeah, thank you.
Yeah, thank you.
Thank you.